All right, so thanks for coming to Why Isn't Your Keyboard Open Source? So I think if you look back at computers from like the 60s, we have like more computing power in your AirPod than like all the computing power combined back then. And so no one would want to live with a keyboard or a computer that would have the same specs as something, half a century old. But I am here to convince you that we live with we're coming up now on 2-century-old keyboard configuration, and a lot of the things that came along for the ride we just think is okay. And on some level, it's a little bit like a chair, like it's an L shape. What else is there to do? But we're going to talk about some of the things that I think is worth tweaking and is worth sharing. And so let's get into it. All right. So we're going to talk about, at the beginning, how we got started here, how we got into the path of the keyboards we see today. We'll go through the history from typewriters all the way up to modern day keyboards. And then, before Ubuntu goes to sleep, we will talk about why that current iteration isn't always amazing, and some of the things that could be improved, or just the warts that came along for the ride as it developed. We'll talk about the ergonomics and what an ideal keyboard setup would be for an input device. And then we'll talk about different layouts, physical and different software that can be flashed onto keyboards if they're an open source variety. And then if we've piqued your interest, how you can get started on the journey yourself. All right, so my name's Andrew Thompson. I'm a software developer at BMW Group, and I have a lot of tech hobbies, but this is one that I enjoy every day. So why care about keyboards? I think the first one for me is we're Linux geeks, we're tech enthusiasts. We care a whole lot about control. And it's like some people might just say, oh, it's just a text editor, but like blood has been spilled over Vim versus Emacs. Like we want to tweak and it comes down to, can you adapt that tool to fit your needs? And why should your keyboard be any different? If we care about the things that are on the desktop, the things that are connected to the desktop should matter too. I used to cycle quite a bit, and bikes are a little bit like computers. And it's fine to get really excited and jazzed up about your new carbon fiber frame, your aero wheels, the components. But if you cheap out on the saddle, I'm like telling you, you're gonna have a very bad time, because that is the primary interface between your body and the machine. And it's the same on the computer, that if you do not look at the monitor and the input device, in this case a keyboard, until the LLMs take over and it's all voice interfaces, it's going to be a bad experience if you are cramped and inefficient. And then finally, this is like a practical hobby. So I have a junk drawer full of Arduino projects that I built once and never touched again. You've got your overbuilt home lab that is over-engineered and over-automated to host a 2-page website that 10 people have visited. At least that's how mine is. And but this is something that if you put some time into it, you get to use it every day, and it actually makes you more efficient in the way you work. So I think it's a thing that gives back to, it's a hobby that gives back to you as well. All right, so we're going to start with a little bit of history here. So the story of how we ended up with the keyboard you have today starts in 1867, actually, when this man here, by the name of Christopher Sholes, did a demo of his prototype of a keyboard in Milwaukee, Wisconsin. Now, over the next 6 years, this would lead to the QWERTY keyboard that we all know and love today. But Sholes was not the first person to come up with the idea of a keyboard. There was a lot of people of prior art in this space. There was a French guy, Plume, who had the typographer, this typographique thing right here that you had to like pull on little hooks. And there's even a Danish guy that had this writing ball that got a little bit of commercial success. Like Nietzsche actually had one of these when he started cramping up from scribbling out his books, but it just never quite caught on. So Sholes wasn't the first, but he iterated through a series of prototypes. The first ones looked a little bit like a keyboard, like a piano keyboard. He got into things a little bit closer until eventually we landed at the thing that we all know today as a typewriter. And so Sholes built his typewriter with several partners, But this man, James Densmore, was sort of the Steve Jobs to Sholes' Wozniak, and he brought it into the spotlight. And he partnered in 1873 with E. Remington and Sons, that Remington, who had recently brought to the market a successful line of sewing machines. And so the engineers at Remington borrowed several elements from the sewing machines and built the Remington #1 typewriter. And so this thing it's kind of like the Model T, the Sony Walkman. It defined the whole segment, and everybody kind of copied a lot of the design cues after this to include the layout, which you see is honestly not that far from what the average computer keyboard is today. There's a few changes, like you had to use that for the 1, but this is not that far. And obviously, QWERTY was the best thing for all typing, and we've been happy ever since, right? Not exactly. So raise your hand if you've ever heard any of these theories about QWERTY, that it was made to purposely slow you down so you could type typewriter on the top row, or just Sholes had a deep-seated hatred for humankind and wanted to make something that was painful to type on. It turns out that there was actually a lot of other people that shared those feelings, and there was a lot of alternate layouts. So you had this Blickensdorfer scientific keyboard. Sholes himself split with the company and made his own keyboard in 1896 with a different layout that was a little bit more ergonomic. But the kind of grandfather of all the alternate layouts was a man named August Dvorak, who in 1932 came up with an alternative in his 1936 treatise called Typewriting Behavior. So this is part dissertation and part sort of a QWERTY shitpost. And it basically had all kinds of reasons why QWERTY was bad, infographics showing how QWERTY utilized fingers not in an even way. And he had a point. And if we look at a heat map here, ideally your fingers move as little as possible when they're on a keyboard. But looking at QWERTY, you kind of have to jump up to the top row, jump down. And Dvorak and more modern iterations like Colmac or Workman do a lot better job of that. But before we jump too far down Sholes' throat, I think it's important to look at the purpose of QWERTY. So the main thing that he designed QWERTY for, and here, get this to focus. This is a modern keyboard. And what he was really trying to do is common English words should have letters that were not right next to each other so you wouldn't get a type bar lockup. And that is actually what QWERTY is extremely good at. Scientists and academics have analyzed a lot of other keyboard layouts. And for the 1800s, the 19th century technology of how they're machining the type bars and everything like that, you actually would get more lockups with Dvorak than you did with QWERTY. So even though he was building it in a workshop, he did an excellent job of designing it for what they needed it to be. But it was pretty good at what it was built for. And because you'd have to retool your factory, all the people that learned to touch type on QWERTY were going to learn an alternative layout. The switching costs were just too great for anything other than QWERTY to catch on. Try as they might, there were arguably better alternatives. But one thing is you actually need to be typing that fast. Now, back in the late 1800s, early 1900s, when we didn't have photocopiers, you had humans that were just rote copying documents with a typewriter. And so raw speed, getting up to 300 words per minute, was actually a pretty important thing. And so the argument could be made that they should have switched back then. Nowadays, they say that the average person only thinks at about 75 to 150 words per minute. So if you can achieve that on QWERTY, Dvorak, whatever, you're probably in an okay place to do a lot of tasks like, programming, writing emails. I know when I'm doing programming, I'll sit and think sometimes for, an hour, and then I'll type for 10 minutes, because a lot of it's just figuring out what you're going to type. So having the absolute most efficient isn't always the best thing. But having the flexibility to choose it or change it if you need it is something that I think we should care about. Okay, so Again, looking at that Remington number 1, what do you guys see that is missing from a modern keyboard? Yes, lowercase. So if we, there were different typewriter manufacturers that had different solutions to this. Some people just stuck another keyboard on top of the keyboard to get the lowercase. But the Remington Model 2, number 2, came out with a shift key. And again, this, the reason they call it shift, let's kick our type bars back here, is that we are literally shifting the platen down to hit a different character on the type bar. And so that was one of the big evolutions to get towards the keyboard that we have today. And shifting is the first layer modifier that changes all the keys on your keyboard to actually become a different character when you hold down one key. And that's an important concept that carries through to our modern day keyboards. Like when you hold Control D, that's not a D, you're sending a different key sequence by holding something down. All right. But there's a few other things that we're going to need to get to the Model M, which is kind of the peak of our keyboards today. Oops. All right. And the two things that we're going to borrow technology from are actually punch cards and the telegraph industry. So starting out here in the 1890s, right as the typewriter revolution was heating up, a gentleman named Herman Hollerith invents a punch card machine that combined the whole no-hole binary encoding of a train ticket with early versions of a calculator known as a tabulator, and he'd made this machine to speed up the US Census. He turned this venture into what we now know today as IBM, and along the way they realized there was a huge market for the ability to normalize data into cards and just crunch data. And it's part of the reason IBM became the behemoth it did. And at the beginning, they started with a more generalized implementation that can process any type of data. But the early machines, as they were punching the cards here, they used something called a pantograph. You had to swing an arm to do each of the punches, almost like a train conductor's hole punch. And that was a pretty inefficient way of entering the data before it went into the hole punch machine. So they did what today might seem obvious, and they just grafted a keyboard or a typewriter on top of that hole punch machine. So zooming in on that keyboard, you can actually see some early predecessors to numlock, backspace, and which is the correction key, and modifier keys. Like we have the alpha versus num, we see some of these like feed and dupe. And then on the other side, the telegraph revolution came into widespread usage around the same time, the first half of the 19th century. But right as QWERTY was hitting the market, a Frenchman named Émile Bordeaux created a fixed baud, fixed length character encoding scheme for character transmission that enabled the development of the first teletypes. So instead of just being the Morse code, what they were doing was sending this data with really 5 bits down a telegraph line, and they hooked it up to a typewriter. So the early teletypes looked a little bit more like a piano keypad because they only had 5 bits of data, but you had to learn sort of like a stenographer a different way of typing. So eventually they did the same thing as the key punch operators, and they just grafted a typewriter onto the teletype machine. And they basically, there's a standardized interface called ITA that is kind of the predecessor to your dev/TTY. And so Linux geeks have taken teletypes and hooked them up to their like dev TTY so that you can have your console print out onto a physical sheet of paper, which is kind of cool. But what those keyboards brought about was a few other technologies we see on keyboards today. To include, so this is a Model 28 machine from 1951, and there's some keys that are kind of familiar. There's layers again, so you see letters versus figures. which is a pretty useful concept. And because the teleprinter is running automatically, it takes time for the carriage to return back to the left and for the platen to advance the paper up. So there is a carriage return as well as a line feed key, which today we still have those in Linux, like you have like /n or like the CRLF. But for backwards compatibility, you used to actually need to do both, but now we really only have like a line feed key. We don't need to bring the platen back, but those still exist in ASCII that goes back to the teletype days. We also have early macros here. So we see here is and who are you. So back when you had multiple teletypes hooked up to the same line, you were wondering who was on the other side, you could type who are you, and it was like a macro, it would type out who are you. And then here is, you would program in your station identifier, and it would automatically send that across the line, which that's a pretty cool feature. And it turns out we can still do that today. We can put in our own macros onto keyboards if they're programmable. All right, so we got through there, but now computer keyboards are starting to emerge. And at the advent of computers, the earliest models were programmed with actual physical switches, like you see in this picture, where they're flipping ones and zeros on these input panels that are, the memory registers that the CPU is actually going to crunch. But that's a pretty inefficient way to input data. And so just like the teletypes, just like don't go to sleep now. Just like the hole punch, we immediately grafted a typewriter onto those computers. And so you see, like, this is an IBM 360 where we actually have a video terminal as well as a typewriter-based terminal on the right. And then finally, the thing on the left is actually a console, which is sort of like the AWS console, which is a GUI that's meant to give you like a picture of where the system state is and do a few automagic things. But it's probably a bad idea if you are building out your whole web app through the console. You should probably do it through the teletype, through something more like this, and that holds today. So we got up into the early 70s and 80s, and this is really the golden age of keyboards. We see the IBM Model Fs, Model Ms with the beam springs, great feel. We see people trying out cool designs, black keys, just interesting stuff. Let me switch over here to, we see like weird stuff. Like this is a IBM partnered with a company to make Keytronic, to make this Flex Pro. This thing, you press a button, and as you twist this, it actually splits and turns into an ergonomic keyboard. Like they were doing crazy stuff and trying things out that you just don't see that often today. And I think it's because computers were so new and so expensive that the cost of adding a little extra effort into the input device was more reasonable. But, let me get back to the slides here. And so you also see stuff like this is the Space Cadet keyboard. This was in the MIT Lisp lab. This is a keyboard made just for like their Lisp research. And so there's all these like crazy glyphs. Like if you zoom in here, there's like pictures, there's like Greek symbols, there's like all kinds of cool things you just don't see on keyboards. There was like experimentation and the materials were high quality. But we get to the dark ages, and as the market matured, companies had to find cost savings somewhere, like to get into the PC market. And so we see the rise of membrane and foam and foil key switches, which have kind of a mushy, unpleasant feel to them. I think for me, the worst part of this is, I've actually got one right here. The Rolly keyboard is about as bad as you can get in a membrane keyboard. It's mushy, it's unpleasant, and it's not what you want. So that was really the dark ages, which is kind of where we still are today to some extent. Because of the rise of gaming, mechanical keyboards have kind of brought some of the high quality companies back, but we're still living with a lot of mushy membrane keyboards and still standard QWERTY layout, and just like not a lot of improvements have been made in the last couple decades. So what is bad about these? Well, first of all, they're not open source. And so if you don't like the layout, if you don't like the the control keys, the macros on your keyboard, there's not much you can do about it. That's just, it's baked into the microcontroller on the keyboard. And that's not something that you should be able to configure that yourself. Second, as we discussed before, the quality has dropped significantly from a couple decades ago. And then last is we're living with a lot of ergonomic compromises that go back to that typewriter era that they're still there because that's what people know and aren't really asking for anything better. So a few things that are not ideal for an input device is, the first is that most keyboards are staggered. The reason for this, to go back to our actual keyboard here, is that these type bars need to slide in between each other. So for this type bar to go, like it would hit the back of the Y if they were lined up in columns. So they had to do that. Similarly, just to clear the type bars, this whole thing is stepped up. It's like a stair step, which is pretty bad for your hands to be tilted backwards. And it's all in one key bed, so it's fixed. You can't really move it around. And then there's two, these are kind of medical terms here. Ulnar deviation is bending your wrists kind of outwards away from your body. And then overpronation is the turning of the wrists on the kind of axis of your arm in. And you're doing both of these when you stick your hands onto like, especially like a laptop keyboard where they're just stuck in that fixed position all day. And then we talked about the extension of, they had the little kickstands. I think for people that got used to typing on typewriters or something, but that's actually really bad for your wrists again to be bending them back. So what can we do that would make it better? Well, one is to stop that staggered layout, have a ortho or columnar layout. The difference between those two terms is ortholinear means that it's set up in a grid, so it's rows and columns all rectangular. Columnar means that it is actually staggered, so it's still in columns, but not necessarily in rows. So like this keyboard here, you can see not all the tops of here line up. And similarly, splitting the keyboard apart allows you to move your hands around throughout the day to get a more comfortable feel for where you want them to be. Having an alternate pointing device is another thing that can really improve the ergonomics, because moving that one arm can cause a lot of shoulder fatigue. And so, IBM with their track point kind of solved this a long time ago, but it's pretty uncommon to find something like a track point in a modern keyboard. But they're coming back, especially in the kind of enthusiast keyboard community. You have track points, track circles, the actual like small mice. There's a lot of different solutions, and so you can find something that fits your needs for the kind of work that you do. And then finally here, tenting is when you tilt the whole keyboard up and lift it off of the surface, which fixes, going back here, that overpronation. And so one other thing we can do to change the keyboard is having an alternate key layout, the size of the keyboard. So 104 keys is what we call full size. That's like your big IBM Model M, like juggernaut. But because like we said, the fewer keys you touch, the less you move your hands, the better. So you can get all the way down to like these 40% keyboards that will use a lot of layers and chording to kind of, you hold one key like shift. So instead of having two keyboards like we saw with the I think Smith Corona, where you got to move up, you can hold down one key and then the rest of the keys, like a different row, might be on the home row. If you are thinking about dabbling this, I would say change one thing at a time. Like don't jump to ortho and 40% all in one go, or you're really gonna, it's a large change to make all at once. But I would say moving down to like a 10 keyless, like these 87 key to 80%, can actually be good depending on the kind of work you do, unless you need that dedicated number pad. Another thing you can change out here is key switches. So this is a pretty deep area. There are whole communities that geek out about key switches. There's actually a Carolina Mech group here in Greenville that builds and designs their own keyboards that they source like esoteric key switches from like limited drops and stuff and sell them for buku money. But in general, they go down into a few different categories. There's blue, brown, and red. Blue means that they're very clicky. Brown means there's a tactile bump as you depress it. And red, there's a linear amount of feedback. There's not like a chunk as you get past actuation. And the only thing you feel is if you bottom out the key. I've got here, for once we're done with the talk here, a set of key testers, and you can try out some different key switches to see if you have a preference on what you like to type on. There are the keycaps that you put on top of those switches, there are different profiles. The SA ones right here are going to be a little bit more sculpted. More popular these days is lower and lower profile because it allows you to shrink the whole keyboard down. And what you really want is to be able to have a keyboard that's portable enough that you can take it with you, so that once you've dialed in your settings, you can take it at work, you can take it if you're at the library, you can still plug your keyboard in. So having some of these smaller key caps are helpful. Back at the top here when we're looking at keys, there's also a company called Kale has these chalk keys, and there's others that have copied them now with the same form factor. These are closer to a laptop chiclet, so you can still get a mechanical key switch in a kind of laptop keyboard size, and they still come in the blue, brown, red, but you'll have even thinner keycaps that aren't shown here if you go with the chalk style key switches. And if you are buying your own key switches, just make sure you get double shot PBT. What that means is that they use 2 colors of plastic to cast. And so the legend, which is the letter or symbol that is printed on it, is actually a different color of plastic. So no matter how long you use that keyboard, for 100 years, you'll never wear the legend off. When companies are cheaping out, they'll use ABS, which gives you that shiny look that you've ever walked up to a keyboard, that like the letters are all rubbed off and the whole thing gets slick and shiny. That's usually ABS plastic. So double shot PBT is the way to go. And then the other thing you can do is change the firmware. So in the very early days, people were just taking Arduinos, writing some C code, and hooking some switches up to them. And that's still an option if you want to. People still do hand soldered matrices and spend a lot of time making these things very carefully. But there's one project called QMK, Quantum Mechanical Keyboard, that has kind of taken over as the de facto project. If you are making a keyboard, most people would expect an open source keyboard project to support QMK. And so this runs on a variety of microcontrollers, from your typical Arduino like Pro Micros to more recent like Raspberry Pi 2040 microcontrollers. And they have configuration files that let you set the key map, let you define if you're actually building from scratch a keyboard, where all the keys are laid out. And then it flashes it in the same way that the Arduino IDE or program is really just kind of window dressing on top of a bunch of microcontroller manufacturer tool chains, where it's running the kind of like shell commands to compile your C code down to the bytecode of a microcontroller. QMK kind of does that work too, where they abstract away some of the complexity of flashing your own keyboard. There's a fork of that called ZMK, which is made to run on the Zephyr real-time operating system, which, among other things, has very good wireless support. So if you want a Bluetooth keyboard that you are making yourself, ZMK is usually what people reach for nowadays. But in a lot of ways, it shares a lot of similarities and configuration file formats with QMK. Now there is really a feature that can be turned on in QMK that allows you to have a GUI on top of QMK. Okay, so VIA here, I don't know if you've ever heard of Fermata for Arduino, but the idea is that you can send kind of commands to the microcontroller after it's been flashed. So what VIA lets you do is reconfigure where your keys are even after you flashed it. Because with QMK by default, every time you want to switch one key, if you want to move the A to the S and the S to the A, you have to rebuild and then re-flash it to the chip. VIA lets you do it via a web interface or a desktop app, and it changes it in real time on your keyboard, which is pretty convenient. there were some issues with VIA, and so there is a fork called Vile, and that is probably where pretty much everyone is going if you want to be able to configure it. At the end here, we'll show one keyboard that's flashed with Vile, just have an idea of kind of what it looks like. But those are the main kind of players in the open source firmware space that allow you to change what your keyboard does. And I should just note that for QMK, you can really do anything. Like if you want to play Tetris with the RGB lights on your keyboard and you want to do the work to program it in C, you can do that. People have added rotary encoder support, different types of e-ink displays, OLED displays, little apps that count your words per minute, as you're typing. It's a software project and you can send it yourself, as you see fit, which is pretty cool if you have a specialized use case. So some of the things that you can do with open source firmware is adding layers to your keyboard. So as you hold or tap one key, you can flip completely what your keyboard does. So maybe if you're really into gaming and you have like certain shortcuts you want, you could have a layer just for a specific game. You can have a layer for Excel, like some, a Vim layer if you didn't like like say you switch to Dvorak, some of the key sequences in Dvorak are not great for Vim, but you could rearrange that. And so, or just have a Vim layer. Similarly, there's mods and macros. So modifiers, this is an example of where, just like where you hold shift, basically if you tap a key, I think they call this mod tap. So this person has it set up where if they hold the N key, it actually turns into a control, and then they can press another key, so it'd be like Control D. Similarly, if they hold the second key there, it's a shift. So they're not overusing their pinkies, they're actually putting them onto the home row mods. You can put macros onto any key. So if there's an unused key like caps lock, you can modify that to type your username or some common sequence that you have to type like 500 times a day. All that's possible. And like I talked about, there's a ton of modules and integrations that you can add here to make it work. So just to give you an idea of what layers look like. So this keyboard is made by a company called ZSA. This is running QMK, so you can flash QMK onto it just like any other. But because they're they're reasonably expensive, they add some nice GUI applications that give you kind of real-time feedback of what you're doing. So as an example, this is the keyboard I use every day for work. If I hold down, which for me is a Enter key, it switches me to directionals like on the left hand. So if I need to navigate quickly, similarly on the other side, let's see here. If I hold down this pinky finger here, I can actually move the mouse around, so I can send mouse commands this way as well. And I mean, you can have media, like this is a numpad / media keys. You can have really infinite layers as long as you have enough keys to add the layer switches. And some of them too can be, you like tap into a layer and tap out. So there's, you're kind of like limited by your imagination on how you want to configure it. I don't know what version I'm up to on like this keyboard, but I usually end up changing some small thing every couple months just because there's like a new VS Code shortcut that I want to like add in somewhere, things like that, which is pretty nice. All right. So, and obviously if you want, you could change the whole keyboard to Dvorak, or you could change it to, one of the more modern, there's Comac Mod DH. There's a lot of enthusiast communities that are researching new ways. Workman, I think, is probably one of the best ones for programmers out there. So if you were starting over and wanted to change to just one today, Workman is one of the better choices out there. But there's always, I think this is like a AI-generated keyboard layout. It's with things like Vile, you can try it out for a day, see if it might be something you're interested in, so you don't have to go like buy a new keyboard or go through some arduous process to try it out. I will say anytime you change both the shape or the key layout, just expect there's going to be a couple week relearning period where you're going to drop down to like 5 words per minute, then eventually get back to 20, and it takes a while to get back to your original speed. So one other thing that's pretty cool here is that in addition to the firmware being open source, a lot of the people out there have actually open sourced the hardware it's running on as well. So right here, this is a GitHub repo called Awesome Mechanical Keyboard. And they've got whole sections of like split, staggered, ortholinear, where you can look at what they provide, whether it's just the PCB, they have 3D printed cases, and they'll generally actually provide, when they say PCB, a KiCad file that you can modify. So I think I cloned down earlier Draculad. So let me actually open up KiCad here, and I'll just show you an example of what that would look like. So once you've cloned down their thing here, we can open up the whole project. And we can get like all the way into, like, if you didn't like where that hole is, we can take it, you know, drag that, you know, select and drag something out of here. You have to like refill it, do the solder masks, but like, or change the schematic. If you needed an extra key, you could add it as long as you could fit it into the net mask or like the schematic here. But like, it's pretty incredible that people have just opened up this work, and you don't have to, you know, start from scratch. Or maybe you do want to create your own keyboard from scratch, but at least you have all these open source reference solutions to see how someone else did it. And that's like pretty cool. And what's also really nice when it's all zipped up in a KiCad folder like this is you can take the Gerber file outputs that they'll often provide, and you can go to PCBWay or JCB, like one of the Chinese fab companies out there, and they will build like this PCB for like $5 to $8 and ship it to you within a week. Which it used to be that if you came up with an idea for like an electronic toy, you would need $500,000 of capital just to get a limited run of circuit boards. And now I can modify this keyboard tonight and have it by next week, which is just like a wild concept that it's gotten that cheap and that fast. And it's cool that everyone's sharing these projects all over the place. Oh yeah, similarly, if you are interested in trying one of these out, let's see here. There's this keyboard, this website that I linked to in the slides that I'll give to Jace after here. But you can basically look at the footprints. I'm not sure why it's not, it basically lets you print out, and it'll be true to scale size. So on a piece of paper, you can try to see, because some of these are bigger, some are smaller, and everyone has different sized hands. Some of them are pretty extreme. And if you just want to try on a piece of paper to see if this is actually something you want to spend, like if you're going to buy the kit, you know, $80 on, this is a nice site to actually see what the layout would feel like if you were touching it with your hands. All right. So if this has piqued your interest, this is the section where we're going to talk about the kind of steps that you could get into it, or the levels that you could get into it. And I feel like there's kind of like small, medium, and then going all in on the custom keyboard adventure. So if you're starting small, like just Puppy Linux, we're not like, you know, going full Arch, you know, compiling it ourselves just yet. You can get, I've actually got one here on the table, a Keychron. They have like C1, C2, where they'll be like 25 to like $40 on Amazon on sale, like especially like Black Friday coming up. You can get a QMK flashable. So this means you can reflash this firmware. And a big thing here is hot swappable keys. Means that you can swap out the key switches if you want to dabble in the red, brown, blue key switch territory as well. So that's, I mean, for $30, it's a pretty amazing deal. And you can kind of grow with it, because there are people out there that will spend $100 on key switches. And if you wanted, you could put $100 key switches in this, which costs more than the whole keyboard. But you could also buy like a $5 replacement key switch set from like AliExpress. So next, saying paying for a seat at table, you can buy pre-made kind of custom flashable keyboards from ZSA, System 76, Mo Ergo, Kinesis, and Keyboard.io are just a few of the, I would say, kind of premium brands in the sector. The thing here is that you're going to pay for it. Just like a System 76 laptop is not cheap. These are going to be in a couple $100, like usually like $200 to $400 range. But as I said at the beginning, like if this is something you use every day, I think this is somewhere where you can kind of justify spending something, especially if you're experiencing RSIs, carpal tunnel pain. A ergonomic keyboard from someone like this can really do a lot to alleviate and improve your working conditions. So just buying it is an option. And then finally, if you really want to go whole hog on this, the Arch Linux route, you can hand wire a keyboard. You can buy kits that you'll be soldering and compiling the firmware yourself from. These are a couple of companies I've used in the past, but this is a pretty wide space out there. So just Google, custom keyboards, and the switches really range in costs. Could be like $20 up to like $200, depending on if you get it with like half pre-built, get it with the switches. Sometimes you'll just get the PCBs and you have to get the components. But there's a lot of different options out there, and it's a pretty wide space. Or like I said, you could just go to one of the GitHub projects, order the PCBs yourself, and source the components. And that's also an option. So that. Oh, and then finally, once you have switched over to something like a columnar keyboard, you're trying out Colmac or Workman, these are some websites that I would recommend to get back up to speed. I really like MonkeyType. I think ZSA has their own software version that's pretty similar to it now, but it's kind of like the typing programs you might have done in grade school, but they're improved and they give you a lot of feedback on specific key combinations. And if you do programming, they can not just give you literary phrases, not just like the quick brown fox jumped over. Like, no, this will be like, I want Python code, or I want C# or something like that, and you can get back up to speed on whatever you use every day. Or I think like Typelet will take literary passages and make you type through them instead of it just being arbitrary sentences. And then finally, if I think Steam actually has this, Typing of the Dead is like a arcade game with zombies that all the zombies have words on them. And it's House of the Dead 2, but reskinned for typing. That is also a fun way to get up to speed. I think that's in my Steam library. It's not a bad option.
Sounds like Number Cruncher.
Yeah.
More violent.
Yeah, so that's basically it. Does anybody have any questions? I can show, the one last thing I can show is if you want to see what QMK looks like, I brought that's a Raspberry Pi 2040, just microcontroller, and I can flash that to basically have arbitrary text on it. But as we turn these around, I can show you like the Kyria right here does have and I'll switch over to the webcam in a second. I threw a little UC Lug picture onto the OLED here. But it's pretty incredible what you can put into these machines, in terms of customization. And I would say if you're familiar with the frustration of working on Linux and not being able to get something to make, you'll have similar, the further you get down into the custom enthusiast rabbit hole, you'll have similar pain points, but it's pretty rewarding when you've, finally gotten to compile and it's working just like you like. And especially being able to combine like 3D printing or other electronics hobbies is kind of cool. So, yeah. So that's all I got.
Question.
Yeah.
So, do they just like emit normal like key codes? Like, if you have your crazy config, can you like plug it into one of the computers?
Yeah. Oh yeah, I never actually muted that. So.
My question is like, if the config goes with the keyboard, like what bits are on the keyboard and what bits are on the.
Yeah, so in the end, it's all USB like HID space. So no matter what you plug it into, if it's a Linux machine, if it's a Windows machine, all it sees, it could be, a Dell keyboard as far as it knows. And so say when you have a macro and you told it, I want you to type, you know, Control Alt Delete Tab Tab Enter or something. You know, like if there was some macro they used a lot, it thinks that someone's just typing on that Dell keyboard as far as it knows. It's just seeing the HID signals come across the USB. I don't know if QMK supports PS2, like the older, or like DIN. This Flex Pro here has the old DIN connector. I'm not sure if you can actually program that in QMK, but usually you're either using USB, or in Zephyr there's a Bluetooth HID spec that's the same thing, where it is sending over Bluetooth the key codes. And you know, you get to pick what the key does, which key code it sends, you know, but in the end it still is transparent to the end device.
Could you show that to the camera?
Yeah, which part?
You were holding up the DIN5 mini.
Oh, yeah. So there used to be a lot different, it wasn't universal serial, it was just serial, you know.
DIN5.
DIN5,
That's mini DIN6.
mini DIN6. I think I have a USB converter for that. The Flex Pro over there, it's a shame. They used foil key switches on it. So it's a very unpleasant, mushy feel, but just the weirdness and coolness of it being a split adjustable keyboard is just stuff that you wouldn't see other places. I brought, so when we're all done, you're welcome to come up here and try out some of this. Not all membrane keyboards are terrible. This is it's really a typing instruction tool for like schools, but a lot of people really like, this is like a kid's, like almost like a children's device for learning to type, but it's a pretty pleasant typing experience. It's not quite the same as mechanical, but you're welcome to try out like the key testers there. One thing I didn't talk about is so there's different hobby communities inside of the keyboard community. There's some people that I would almost call them kind of like the sneaker, like fashion people, where they spend a lot of money and they really like everything to be like set. I'm not sure if they're like, but they're not like playing basketball with these sneakers. There's like vibes of that sometimes where they're like spending a lot of money and they're really into like the thock, they call it, of like the noise. And so they'll add like felt dampeners under, like inside the keyboard. They'll put like silicone gaskets that float the PCB inside the case so that it deadens the sound further, and then spend a lot of money on switches that are like custom lubed inside. But one thing that you can do, and I'll bring this over, and I think I'm unmuted on the shotgun mic here, is you can add bumpers. So inside of the keycap here, they're almost like the little rubber bands that you put on braces, but they're these bumper rubber bands that soften the key bottoming out. And so I think I've got like no bumper there, like one bumper, maybe a couple, and then that's like I have like two bumpers on that, so it feels quite different under your finger too. And so that's like one way you can modify it. These are just this is like a DSA keycap versus, actually I think this is XDA, DSA, OEM, and then these are all chalk keys, but there's linear, tactile, clicky, and a different key cap on these. So it's like a plethora of options. So it's a pretty wide space, but in the end, it's just nice to have to be able to change things and find what works for you. This is my travel keyboard. And so this is a Bluetooth ZMK keyboard. So if I'm not in my like home office or at work, this is usually what I'm taking with me. And I find that it's pretty helpful. You do need to pair it, with whatever device. So if it's a really locked down computer, you might not be able to just arbitrarily add Bluetooth devices to it, versus you can usually find a USB port to plug a keyboard in. But for not being stuck with a laptop keyboard, having a Bluetooth option that compacts down is pretty helpful as well.
Is it cording keyboard?
Yeah, I mean, in the end, you can put anything. So you could cord it if you wanted to.
No, I'm asking because it doesn't have 26 keys.
Yes. I mean, in the end, there's layers, and the layers are going to be what allow you to get all the 104 keys that you would see on a full-size keyboard. Layers are generally how you're going to get back the space that you would have full, if you need that print screen, you can put it on a layer and toggle to it. But yeah, so that's basically it. A couple other keyboards I have here. On the far side of the table over here is a Kinesis Advantage 360. So this is also running a ZMK because it's a Bluetooth keyboard, although you can plug it in via USB. This has adjustable tenting on the base, and because it's not connected, you can move it around, which is pretty nice. And let's see here, this is a Curia. Yeah, there we can see our little UC lug there. Somehow got bumped into RGBs not working, but like you can configure all the RGB animations, in keyboards like this. So those are just rotary encoders. So I think it depends on the layer. I could actually, here, we can switch real quick over to, and then, guy popped it up. So right now in this layer, it's volume and page up down. So like if you're on a website, you could twist one of the knobs and just scroll through the website instead of using your mouse without going off the keyboard. In layer 2, I think I might have had it set up for some of the RGB effects. And then when you're modifying these things here, you just select something. Now that A key is a W, and then you just flash it, and then the keyboard is like that. Although with Vile, it doesn't need to be flash. It changes it as soon as you say like upload, which is kind of cool. Let's see here. Can't remember if I.
Sometime later, you're going to type that A key. So I wonder why it's W.
Yeah, later I'm gonna be like, man, someone's messing with this. But like it's that easy with Vile versus QMK. We could show real quick here. So let's see here. So inside of here, QMK has, they call it direct pins or Easy Maker, where if you don't want to have a full PCB, you can just take a microcontroller and hook switches right up to it. Because a normal keyboard has a matrix where it's scanning across to see which key is depressed. But if you just want to wire up a few switches, like to make your own macro pad, their Easy Maker kind of quick start allows you to just like throw something in a config file, flash it, and then you've got your own little keyboard. So in this case, I think I might actually, let me open up Sublime. So this is an example of what like a default key map would be on my travel keyboard. They're a little bit more complex. You'll see each of the layers. It lets you say like, this does a key press G, and then lower layer, this is key press number 8, so, and basically then this file gets compiled and flashed into the ZMK or QMK firmware. But on this Easy Maker one, since we're only looking at the pins on a microcontroller, I think do that, save it. It's pretty fast. It's it's like making any small software project. And once this is done, it's just going to spit out a UF2 file that you tap a pin on the microcontroller, and it goes into bootloader mode, and you can just, it actually mounts as a USB drive. You can drop that file onto it, and then it's like live. So I think I actually flashed this right before I came here. So what that file is actually doing is I added 2 macros. One, just this string UC lug, and then I have conveniently added for myself, I'm not a Vim user, and I never know how to get out of it. So here we have escape, wait a second, then enter. And so with this plugged in now, if we're back on somewhere we can type, which one did I set this to? It's like now, like as you're just pressing the switch, all it does is just type hello UC lug. That's all this keyboard does. Or if we, let's see here, or I'm lost here. I don't know how to get out. We can press this, and now it gets us out of Vim, which is, like it's that level of control. It's kind of cool to be able to like control that with a small project. So it's a real escape key. God knows, I may have shamefully Googled how to get out of Vim once or twice in my life. Yeah, so that's keyboards. If you, as I'm packing up, you're welcome to try any of these keyboards and see if it's something you're interested in.